Earth is often struck by solar eruptions, but they tend to have little impact other than beautiful auroras seen around the planet's poles. But if these bursts of energetic particles were to become powerful enough, they could devastate our planet, wipe out electricity and even destroy the atmosphere. That's the warning from a group of astronomers that recently discovered our Sun is capable of producing the kind of superflares seen on other stars. Although the researchers said the chances of it happening is low, they added it's not impossible, and one described the findings as frightening. Solar flares occur when large magnetic fields on the surface of the Sun collapse. When that happens, huge amounts of magnetic energy are released. When the Sun pours out gigantic amounts of hot plasma during large solar eruptions, it can cause consequences on Earth. In particular, it can affect satellites and communication equipment. But our Sun's solar eruptions are nothing compared to the eruption we see on other stars, the so-called superflares. Superflares have been a mystery since the Kepler mission discovered them in larger numbers 4 years ago, and astronomers have questioned whether they could be produced by our Sun ever since. They are typically considered solar eruptions between 10 and 100 times larger than the largest solar eruption observed during the space age. An international research team led by Christopher Kara from Aarhus University, Denmark used observations of magnetic fields on the surface of almost 100,000 stars to answer these questions. The team used a spectrum for every star of those available for this analysis. A spectrum shows the colors, or wavelengths, of the light from the stars. Here, certain short ultraviolet wavelengths can be used to measure the magnetic fields around the stars. These observations were made with the new Guoshujing telescope in China. The magnetic fields on the surface of stars with superflares are generally stronger than the magnetic fields on the surface of the Sun, explained Karoff. This is exactly what we would expect, if superflares are formed in the same way as solar flares. This suggests that the magnetic field of our Sun is too weak to produce such superflares, otherwise we would have witnessed them. However, out of all the stars with superflares analyzed, around 10% had a magnetic field with a strength similar to or weaker than the Sun's magnetic field. Therefore, even though it is unlikely, it is not impossible that the Sun could produce a superflare, the researchers said. We certainly did not expect to find superflare stars with magnetic fields as weak as the magnetic fields on the Sun, they continued. This opens the possibility that the Sun could generate a superflare, a very frightening thought, added Karoff. If an eruption of this size was to strike the Earth today, it would have devastating consequences. Not just for all electronic equipment on Earth, but also for our atmosphere and thus our planet's ability to support life. Plus, evidence from geological archives has shown the Sun might have produced a small superflare in 775 AD. One of the strengths of our study is that we can show how astronomical observations of superflares agree with Earth-based studies of radioactive isotopes and tree rings, explained Karoff. In this way, the observations from the Guoshujing telescope can be used to evaluate how often a star with a magnetic field similar to the Sun would experience a superflare. The study shows, for example, that the Sun, statistically speaking, should experience a small superflare every millennium. This is in agreement with the idea that the event in 775 AD and a similar event in 993 AD were indeed caused by small superflares on the Sun.